calculating the small sample confidence interval estimate for mean mu when standard deviation is unknown. Samples confidence interval or small sample confidence interval for mu when standard deviation is unknown if the mean and standard deviation or the mean and standard deviation of a random sample size n is less than 30 from an approximate normal population with unknown standard deviation. When 100 times 1 minus alpha percent confidence interval for mu is given by this formula. Okay, so in here, this alpha over 2 is equal, and n minus 1, this pertains to the degrees of freedom. It's just that if you will notice, so it's just that the same formula, but on the left, you'll have minus, and on the right, you'll have plus, or I should say plus. So where t sub alpha over 2 is the t value with degrees of freedom n minus 1, leaving an area of alpha over 2 to the right. So just as this one, so you have to express your answer in terms of interval. For the t value with degrees of freedom n minus 1, refer to the attached table of critical values of t. I've already introduced to you the t table on our previous activity. So you have to determine confidence interval estimate when standard deviation is unknown. Read and comprehend the following computation of confidence interval estimate below. If you are given is a standard deviation of 6, our n is 20, and our mean is 25, just attach the given to our formula with 90% confidence interval. So our mean is 25 minus, so since 90% is also the same with 10% or 0.10 alpha over 2. Then 20 minus 1 is our degrees of freedom. It's going to be 19. So our t sub 0.05 on the left side of our interval, and on the right side just change subtraction to addition. So we have to remember our given, which is 25 for our mean. So on the table, referring to our table, we just have to look for the value of t sub 0.05 with the degrees of freedom of 19. So on our t table, we just look for 90% degrees or confidence level. So this one, the degrees of freedom is 19. So their intersection is 1.729. Again, just remember 1.729. Okay. So going back, we have to perform 25 minus 1.729. Where did we get that? We got that from our table. So just substitute 6 for your S and square root of 20 for your M. Then just perform that on your calculator. You'll have 22.6803. Then just change subtraction to addition, then 25 plus whatever you will get when you perform this on your calculator. You'll have 27.3197. That is for our interval. And to express your final answer, it's going to be 22.6803 less than mu less than 27.3197. For the interpretation, we have, for the above mentioned example, we say that we are 90% confident that the mean will be between 22.6803 and 27.3197. For our guided practice, our problem will be measurements are made on a random sample of 23 components drawn from a population size of 100. Assume that the population is normal and the mean measurement of the components in the sample are 67.45 mm with a standard deviation of 2.93 mm. So all you have to do is to determine our given. So we have our n, the population size, is equal to 100. Our standard deviation is, on our given, is 2.93 with its mean as 67.45. So if you will still remember, going back to our formula, I'm going to show you the formula. Okay, so on our number 1, once again, we have our x bar is equal to 67.45, and then our t sub alpha over 2 n minus 1 is equal to, you just need to look for its value to the t table. It's going to be 2.074. So next is your n, which is 23, and your standard deviation, I'm just gonna write it here, 2.93. So we already have our given. All we need to do is to perform its indicated operation, or the formula given, I should say. So it's gonna be 67.45 minus, so 2.074. If you have your calculator, you can press it on your calculator. 2.93 divided by square root of 23. So this one means multiplication. I just showed you that its symbol is just the usual symbol of multiplication, which is x. Then close parenthesis. It's gonna be 66.183. Then it's gonna be 66.183. That's gonna be on the left, and then just on your calculator, once you pressed it, you just go back to it and then change the operation involved to, from subtraction, make it addition. That's gonna be, if you're gonna make it addition, it's gonna be 68.717. So this one. So next is just letter B. Same given, but you have to perform that its confidence level is 99%. So our n is still 23 minus 1 for degrees of freedom. This is going to be 22. So same given. So for the second sample, so the question is if the confidence level will be 99% and still our degrees of freedom is 22. Its point of intersection is 2.819. Just remember 2.819. Then what you're gonna press on your calculator will be 67.45 minus 2.819 times 2.93 coming from the given over square root of 23. Then close parenthesis is gonna be 65.7277 or 65.728. Then once again, going back to your calculator, just press this one, change that into addition. So if you're gonna press it on your calculator, it's gonna be, make it addition. So it's gonna be 69.1722, or just simply 69.172. That's it. So for independent practice, you are to answer numbers 1 and 2. No need to answer explore activity. So that's all. Thank you all for listening, and God bless you all.